we have been studying personalized estimation of infection risks on mobile phones since 2017. Here, our group present our research results titled Tracing Patients Plot by Mobile Phone with the Use of Semantic Web Technologies. This movie shows the overview of our proposed approach. To overcome the ongoing COVID-19 pandemic, everybody needs to reduce the risk of infection. For this purpose, many systems have been built to mitigate the infection risks. For example, in South Korea, they have built a GIS system that shows the location of confirmed cases, their address and places they visited. In Malaysia, they have also released a similar system that tells where the infected peoples are. But, isn't there any problem here? Yes. Privacy matters here. In most Western countries, it is unacceptable to release the detailed location of patients, because that violates the privacy of patients. Accordingly, some countries have set up contact trace applications that use Bluetooth technology, which tells the possibility of infection to encourage people to report to authorities for testing, without violating the privacy of patients and residents. Such an issue, the conflict between patient privacy and public safety, has been a major concern of public health authority. And so, when a patient of highly infectious agents appears, such as measles, they have been releasing very limited information only, expecting potential contacts to report to the authority, like an example here. However, in a pandemic, is it possible for residents to check all the press releases to assess their own risk of infection? So, we proposed an approach that works this way. 1. When a patient is confirmed, public health authorities collect information related to the patient. They want to warn the close contacts for possible infection. 2. So, they release anonymized information. 2. We proposed a framework to make it in open data. 3. The data can be used by smartphones of residents to calculate their personal risk of infection. 4. Which asks them to report to the authority for further investigation. Overview. The patient locational open data comprises 3 components: metadata, patient information, and their travel information. Metadata. The metadata defines the structure of a patient report and provides its metadata. Patient information. The patient information is used to describe the patient, and because of this information, PLOD can accommodate various infectious agents aside from COVID-19. Travel information. The travel information is designed to allow flexible description of patient trips, for commuting for work and for shopping, etc. Using the patient data described in PLOD, smartphones now can calculate personal risk of infection. For this purpose, store location of cell phones will be reverse geocoded first to geonames, and then, Sparkle search will be used to calculate the intersection between patients and the smartphone in a flexible manner. For validation of the expressive power of the proposed framework, we collected press releases of infectious diseases and examined their contents. And, we found cases where the proposed framework will not work, unfortunately. First, some press releases contain negation of stay or visit to a specific area. Second, some releases contained information of patient profession, which suggests possibility of trips, but they are not specified. Third, there is some locational information which cannot be converted into coordinates. Lastly, there are cases that have references to other press releases. And thus, we are currently and continuously making revisions to make it more useful. We also found other issues that must be addressed before actual deployment of PLOD. First, information of patient location may have ambiguity. For example, on a bus or train, detailed trip data will be unavailable. So, integration with public transportation databases might be needed here. We also need an application for public health authorities to enter the patient data to generate plot-based press releases. We also found that an infection risk ontology is needed, because the risk of infection varies greatly depending on time, place and occasion. Under the current healthcare system, when an infection is confirmed, the public health authority investigates the patient and publishes the findings in a press release. But there are problems in the practice of press releases. There are independent formats for each local government, without standard in their content. Thus, they cannot be aggregated automatically. Also, there are problems in current contact tracing applications. GPS tracking violates privacy. Bluetooth tracing is not effective enough, unless everybody uses it. So, we proposed a PLOD approach, which realizes personal risk control using mobile phones, without violating patient privacy, with semantic web technology. For this purpose, we designed a structure of press releases using RDF, and proposed a computational and usage model, that realizes Sparkle-based query over patient information and location information stored in mobile phones.